Okay, and we're back to finish up our last transformation for graphing sine and cosine functions. Okay, so again, we need to know what our parents look like, the originals, when all our numbers, our coefficients, our constants are ones. So now we're going to talk about one last shift. We saw in the last video how you can shift the graph left and right, which affects the x-axis, which is degrees and radians, and that was called a phase shift. You could also take the whole graph for sine and cosine and shift it completely up or completely down, and that's called a vertical shift. Okay, so that's what we're going to talk about today. How do you graph a sine and cosine function if you physically pick it up and move it all the way up or all the way down if you do a vertical shift? Okay, in your notes, it says you will know there's a vertical shift because there'll be a number added or subtracted to the whole trig expression. And usually that number's in the front, so you don't get it mixed up with the angle. Remember, this right here is all part of the angle. The angle is x. That's why it's in parentheses. So the number in front of x is the frequency, and the number behind x is the phase shift. But if we add or subtract a number at the very original, the very beginning of the original function, that's going to be our vertical shift. So this letter D is notating the vertical shift, which means I'm either going to move up or move down. Now it does correspond to what you think. If you add a number to the trig function, it moves the whole trig function up. And if you subtract a number from the trig function, it moves the whole function down. So we have 3 examples in our notes. Let's look at them. The first example, y equals 2 plus sine x. So if you look very closely at that, okay, you will notice that we have a number being added. There's a plus sign here to the whole trig function. So again, I'm a creature of habit. I list everything I need to know. To graph trig by hand, I need to know my amplitude, my frequency, my period. I need to know if there's a phase shift. And now I'm going to write a vertical shift. Okay, VS for vertical shift. All right, we know our amplitude. It's the number connected to the trig function by multiplication. Here's the trig function. There's a number here connected in front. That's 1. That's your amplitude. We know the frequency is connected to the angle by multiplication. There's my angle. My frequency is 1. I know to get my period, I do the formula 360 divided by my frequency 1, which is still 360. Do I have a phase shift? Here's the angle. Do you see anything being added and subtracted to this? No. So there is no phase shift, which means this graph is going to start at 0 degrees. Good. But there is a vertical shift. There is a plus 2 being added to the whole trig function. So that vertical shift of plus 2 means we're going to move this whole graph up 2 units. Okay? Is everybody good with that? Great. Now, if we move our trig function up 2 units, okay, if we move our trig function up 2 units, that is not going to affect the x-axis, that's going to affect the y-axis. So the vertical shift is going to work with the amplitude. These two are going to go together. The amplitude and the vertical shift both affect the y-axis. So here we go to set up. X, y. Okay? Normally we put the amplitude first, but we can't because the whole graph is going to move up 2 units. So that's the first thing that's going to go on the graph is the vertical shift. We're going to say, okay, starting here, instead of starting here at the origin, we're going to physically move this up 2 units. So we're going to count 1, 2. And the way we're going to show it's moving up 2 units is we're going to draw another horizontal line. And we're going to make it broken to say it's invisible. That line has a name. It has a funny name. It's called the sinusoidal axis. What you're doing is you're saying, instead of the sine curve revolving around the x-axis, see how it goes up from the x-axis and down from the x-axis? This curve we're going to graph is going to go revolve around this new axis, the sinusoidal. Okay? So when you have a phase shift, you put that in first. Now from here, the amp's going to go up 1. So if you're at 2 and you go up 1, the curve can go as high as 3. And you're going to go down 1. From 2, if you go down 1, the curve is going to go as low as 1. So when you go to graph this sine curve, it's going to be sectioned off between 1 and 3. None of this curve is going to be down here. Okay? So before you put the amp, you put the vertical shift. And then you count the amp. Frequency still means we're drawing one curve. The period is 360. So we break the period up into 5 units. So from 0 to 360, halfway is 180, halfway is 90, halfway is 270. There is no phase shift. So all we need this is in radian measure, which we have memorized. We know 0, 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, 360 is 2 pi. So we still label the x-axis. Now when we go to plot, look what happens. It's a sine curve. A normal sine curve should begin at the origin, 0, 0. This is not beginning at the origin because you said it's going to shift what? Up 2. This is where the axis you're beginning with. You're beginning here. Then you'll go up. So at 90 degrees, you go up to 3. At 180, you'll hit this new sinusoidal axis. At 270, you can only go as low as 1. And at 360, you hit the sinusoidal axis. So see how the sine curve is revolving around this new axis? And then you'll connect. How do you like that? Pretty cool? All right, let's try the next one. Now I'm going to erase my equation here. I'm going to erase my work. Erase my graph. The next one in your notes. I want to graph y equals -1 minus cosine 2x. Okay? So, here's my equation. I need my amp. My amp is always in front of the trig function. What's understood to be that number? -1. But can the amp be negative? No. So we say the amp is 1, and the negative means it's going to be reflected. It's a reflection. Frequency is the number in front of the angle. That's our 2. Uh-oh, we got to draw 2 curves. That's going to affect our period. Our period is going to be 360 divided by 2, which is 180 degrees. That's going to tell us I need 180 degrees to make one curve. So between 0 and 180, there's going to be 5 points. Do we have a phase shift? Well, no. There's nothing being added or subtracted to angle x. So the phase shift, there is none. We're still starting at the origin, 0. All right. But do we now have a vertical shift? Sure we do. I have in very front of here a -1. If the vertical shift is a -1, that means the whole curve is moving down 1 unit. That's what that's telling us. This whole curve is going to go down 1 unit. All right, let's set up our axes. Here's x, here's y. Normally when we set up y, we start with the amplitude. But you cannot, because you have a shift. So everybody look at me. A cosine curve revolves around the x-axis. See how half of it's above and half of it's below, right? You're shifting this whole graph. You are now shifting this whole graph down 1. So the first thing that goes on the y-axis is the vertical shift. We're going to shift down 1. And the way you show that is you draw a new axis. Once you put the vertical shift, now move the amp. From here, at -1, you can go as high up 1. So if you're at -1 and you go up 1, you'll only reach 0. If you're at -1 and you go down 1, you'll go to -2. So right now, before I ever graph this cosine curve, I know it's going to stay right here between 0 and -2. None of it's going to be above the x-axis. Okay? I put the shift on first, and then I add my amp and I subtract my amp. Frequency means I'm going to draw two curves when I'm done with this. So now I'm going to get my x-axis set up using my period. My period goes from 0 to 180. I separate that into 5 parts, so halfway is 90, halfway is 45, halfway is 135. There are the 5 points to make the first curve. We're drawing two curves. So the next curve would start at 180, and if I go another 180, it would end at 360, and everything is going up in increments of 45. So 180 plus 45 is 225, plus 45 is 270, plus 45 is 315, plus 45 is 360. So now I have all my x values as angles, degrees. Do I have a shift? No. That's great. We're starting at 0. All I need all these in radians. Again, no crying. 0 degrees is 0 radians. 45 is pi over 4. If that's 1 over 4, then 90 is 2 over 4. 2 over 4 is a half. 135 is 3 over 4. 180 is 4 over 4, which is just 1 pi. 225 is 5 over 4. 270 is 6 over 4. 6 over 4 reduces to 3 over 2. 315 is 7 over 4. 360 is 8 over 4, which is 2 pi. So now I have all my radians. I'm going to put them on the x-axis. So here's 0, 45, 90, 135, 180, 225, 270, 315, 360. Make sure if you're doing this on graph paper, everything's equally spaced. Now all I got to do is start plotting. So I read. I am graphing cosine. Cosine is supposed to begin up here, but this graph is never getting that high. The highest the graph is getting is up here. So at 0 degrees, it would be up here at 0. But wait, the negative meant it was reflected. So instead of my cosine starting up, it's going to start down. So at 0 degrees, I'm starting down. This is the axis I'm going to hit at 45, and then it's going to go up here to 0, pi over 2. It's going to hit my sinusoidal axis. It's going to come back down. That is one cosine curve completely upside down. Now I do it again. I hit my sinusoidal axis. I go up to 0. I hit my sinusoidal axis. I'm back down at -2. You told me this curve can only go between 0 and -2. Look at it. It's all between there. All right, we got one more to practice. So let me get our last equation. Okay. Our last equation in our notes is the big one. It's got everything. All right, so let's erase this. All right, you ready? This is the fun. I love this stuff. I think this is so cool. Y equals -4 plus sine 5 sine 2/3 x plus pi over 3. Okay. Don't be afraid of the equation. I want to graph sine. It's going to look something like the parent. But every number in there means something, and that's what you're learning. The numbers mean something. So, to graph a trig function, I'm a creature of habit. I write everything down. I need my amplitude. I need my frequency. I need my period. I need my phase shift, and I need my vertical shift. Okay, those are the 5 components I need. 4 of them I get from looking up here. I know my amplitude. It is the number connected to the trig function by multiplication. It is 5. It's a positive 5. Good, there's no reflection. This sine curve is going to go as high as 5 and as low as -5. I need my frequency. Uh-oh, my frequency is 2/3. I'm only going to draw 2/3 of a curve. I'm not going to draw a full curve. Well, that's going to affect my period. My period is always 360 divided by frequency. I know you all have calculators, but just to review, 360 divided by 2/3 is 360 times 3 over 2. 2 goes into 360 180 times. 180 times 3 is 540 degrees. So for this equation, it's going to take 540 degrees to draw a complete curve. But wait, do I have a phase shift? Heck yes, I do. Here's the problem. You all are going to jump the gun and say the phase shift is plus pi over 3. To tell me the phase shift, what's the coefficient got to be here? A 1. So you guys have got to factor out the 2/3. So if we pull the 2/3 out, 2/3 divided by 2/3 would be 1x. Now you got to take pi over 3 and divide it by 2/3. You don't want to type that in your calculator. You're going to get a decimal. That's why we're going to know how to divide fractions. So pi over 3 divided by 2/3 means pi over 3 times 3/2. The 3's would cancel, and that would leave you with pi over 2. So to tell the phase shift, the coefficient in front of x has to be 1. So if there's a number in front, factor it, divide it out. So now our phase shift is plus pi over 2, which means we're not moving to the right, we're going the opposite, left, and pi over 2 is 90 degrees. But wait, we also got a vertical shift. There is a number being added, subtracted to the whole trig function. It's -4. So if the vertical shift is -4, it means we're going down 4 units. Every number in that equation means something. Those numbers affect how you set up the x and y axis. So here we go. Here comes the fun. To set up the y-axis, we can't start with the amplitude because we have a physical shift. We are physically taking this curve and shifting it down 4 units. So everybody count down 4 to -4 and draw your new axis, your sinusoidal axis. So look, the sine curve isn't going to revolve around the x-axis. It's going to revolve around this new axis. Now, from here, we can only go as high as 5, which means if you're at -4 and you go up 5, what number would you be at? 1. And you can only go as low as 5. So if you're at -4 and you go down 5, you'd be at -9. So what happens is when you're looking at the graph, your sine curve's got to be between 1 and -9. Okay? So phase shift, vertical shift goes on first, then the amplitude. Now we got to get the x-axis. So we got to use our period. Our period starts at 0, goes to 540. Halfway is 270. Halfway is 135. So this is going up by 135. So I added 35, I added 135, so this would be 405. But am I starting at 0 degrees? No. Remember, the period gets affected by the phase shift. I say I'm shifting everything back 90. If I'm going back, I got to subtract 90 from all these guys. So 0 minus 90 is -90. 135 minus 90 is 45. 270 minus 90 is 180. 405 minus 90 is 315. 540 minus 90 is 450. Everybody with me? So the period was 540. So from 0 to 540, you had to split it into 5 parts. Okay? But now we had a phase shift back 90, so I subtracted 90. Everybody's good? All right. These all need to be in radian measure. We know what -90 degrees in radian measure. It's -pi over 2. We know what 45 degrees is in radian measure. It's pi over 4. We know what 180 is in radian measure. It's pi. You're going to say, well, how the heck do I get 315? Well, 315 is a multiple of 45. That's one way to think of it. How many 45s make 315? 7. So this is 7 pi over 4. Okay? 450 is a multiple of what, y'all? 450 is a multiple of 90, right? 0, 90, 180, 270, 360, 450. How many multiples of 90? 5. So this is 5 pi over 2. Okay, so you know your multiples. Okay. Another way of looking at it, between 45 and 180. 45 is 1 pi over 4. 180 would have been 4 pi over 4. So to get from 1/4 to 4/4, you would have to add 3/4. So if this is 4/4 and you add 3/4, you get 7/4. If you're at 7/4 and add 3/4, 7/4 and 3/4 would be 10/4. Doesn't 10/4 reduce to 5 over 2? So that's another way of looking at it. Now, do we need to use all 5 of these points? No, because we're not graphing one complete curve. We're graphing 2/3. Okay, so if we're graphing half a curve, we need 3 points. So to graph 2/3, we need 4 points. So now we're going to label our x-axis. All right. What does negative pi over 2 stand for? That stands for negative 90 degrees. So everybody look at me. I'm going to put the blue lines in because it's all about skipping lines. We know this is at 0. So here's a line, and if you make this line negative pi over 2, okay, that meant from 0 to here is 90 degrees. The next line you want to put is 45. So the question is, to put the 45, do you skip a line and put the 45 degrees here? No, that doesn't make sense. If you skipped a line from here to here is 90, so if you only want 45 degrees, it'd be right up next to it. That'd be 45. So if you look, there's 1, 2, 3. So everything goes 1, 2, 3. Here comes 180. 1, 2, 3. Here comes my 7 pi over 4. Two things have got to happen, especially when you're drawing negative angles. You have to make sure whatever you label here makes sense over here on the right. If from 0 to negative 90, if you skipped a line and made the second line 90, that means over here the second line would be positive 90. So you don't want to label that 45 degrees. 45 degrees would be in the middle. Second thing, you're going to make sure between this radian and this radian is the same equidistance. 1, 2, 3, 1, 2, 3, 1, 2, 3. Now all we got to do is start. What trig function are we graphing? We're graphing sine. Sine is supposed to begin at the origin. We should be beginning here, but we had two things happen. First of all, we had a vertical shift. Everything shifted down. And we had a phase shift. Everything shifted to the left 90. That's why the first point goes here. At negative 90 degrees, negative 4. The next point should be at pi over 4. And it should go up. It should go as high as 1 because that's the highest point. The next point at 180 should hit the axis. Now we're hitting the sinusoidal axis. And the next point, 7 pi over 4, should go as low, which is negative 9. This should be 3/4 of a sine curve, which it is. So now we finished how to graph all our trig functions for sine and cosine using all the transformations you're going to see. Changing the height, shifting it vertically, changing the period, changing the frequency, and shifting it horizontally. The next video I'm going to show you how to, when you go into MyLes Plus, how you click to make the graph so you understand how to work the buttons. Okay, so our next video is going to be all about MyLes Plus. I'll see you then.